Hello everyone, welcome to my channel Chemistry by ANR. Today's topic is properties and reactions of alkanes. When we talk about properties of alkanes, we should know that most of them, or I'll say almost all of them, are non-polar molecules because they contain all covalent bonds, be it carbon-carbon or carbon-hydrogen, due to very less electronegativity difference. So they are, first thing what I said is they are non-polar in nature. Since they are non-polar in nature, they are soluble in non-polar solvents. And third thing, which I have already told, that their boiling point order will be what? If there is increase in branching of the alkane chain, then what will happen? The surface area will decrease, for which the van der Waals interaction decreases. And there is a decrease in the boiling point. Now, if the size of R increases, then obviously the boiling point needs to increase because the molecular mass increases with increase in the hydrophobic part, which is R. Now, the entire molecule is hydrophobic because it is non-polar in nature. See, we can see it is hydrophobic in nature. Now, we have seen already that it dissolves in non-polar solvents as like dissolves like. So, try to explain it with the nature of the solvent. Since the solvent is non-polar, so since the solute is non-polar, it will be soluble in non-polar solvents. Boiling point, we have already said, with increase in the molecular mass, the boiling point increases. With increase in branching, the boiling point decreases. So next, chemical properties. For chemical properties, we have to see reaction, which is the main reaction of alkanes. The main reaction of alkanes are substitution reactions, as they are saturated compounds. Since they are saturated compounds, the main reaction that can take place in alkanes is substitution reaction. And we can see halogenation reaction at a higher temperature or in presence of sunlight or ultraviolet light is an example of substitution reaction. This halogenation favorably can be chlorination or bromination. So here, if it is, please do the correction, it is methane. Over methane, there are 4 hydrogen atoms, and with 1 mole of Cl2, it is monochlorination. It substitutes 1H of methane and it forms chloromethane, CH3Cl. It contains 3 replaceable hydrogen, and when you treat it with Cl2 again in presence of H nu, it forms dichloromethane plus HCl. When you do chlorination again over dichloromethane in presence of sunlight, it gives you trichloromethane, which is also known as chloroform, and it gives you HCl as the side product. This chloroform again in presence of Cl2H nu gives tetrachloromethane or carbon tetrachloride. Since there are 4 replaceable hydrogen in methane, so the substitution can take place with 4 moles of Cl2. Here we can see 1, 2, 3 and 4. With 4 moles of Cl2, the entire of the replaceable hydrogen will get substituted by 4 chlorine, and it occurs in stepwise manner. So here, variation of melting point and boiling point. If we compare the boiling point, when the branching increases, the boiling point decreases. We can see it is happening here. That's why it is being given to show you the comparison. Here, ethane, monochlorination of ethane. This is ethane. When you use 1 mole of chlorine in presence of H nu, then it is 1H of ethane getting substituted by Cl. So it is found that the rate of the reaction of these alkanes depend on the type of halogen that you are using. Is fastest in fluorine for fluorination, then chlorination, bromination, iodination. But then why I am not showing you the example of fluorination and why I started that it is better if X is equal to Cl or Br. Let us see why. Fluorination is very fast, too violent to be controlled. So this reaction cannot be controlled. And moreover, if I have more branching in the alkane, if it is a 3 degree, then a 3 degree has a higher rate than 2 degree, then 1 degree alkanes. So this depends on, number one, rate of the reaction depends on type of alkanes. If it is a 3 degree alkane, rate is greater than a 2 degree than a 1 degree. And number two, it depends on type of halogen which you are using. The rate of the reaction is fastest for fluorine, then for chlorine, then for bromine, and then for iodine. But these are the two things which you will use. This you cannot use, and this also you cannot use for these reasons. Fluorination being very fast reaction, very violent, you cannot control. Iodination, in the contrary, is very slow and is reversible reaction. We can see reversible reaction. So what happens is, it can be carried out, but it should be carried out in presence of oxidizing agents like HiO3, HNO3. These are the oxidizing agent that can oxidize the Hi2I2 in order to drive the reaction forward, as it is a reversible reaction. So anyone can ask you a question that if you have to do iodination, why will you require HiO3 or HNO3? Or you may be told to suggest the oxidizing agents, and these are the two probable oxidizing agent. The mechanism of this halogenation is a free radical chain mechanism where it has 3 steps in any free radical reaction. First is initiation, then is propagation, and then is termination. So we can see the initiation step. Let us do some corrections over here. This is a homolysis. Half arrow here, giving you Cl dot. But remember, this is CH3Cl. So what is happening over here is half arrow here and half arrow here. So you get a CH3 dot and you get a Cl dot. But this step is completely, you will not write this step, because chlorine free radicals, when you are getting it from, this cannot be the first step, because when you are getting this, don't write this methyl over here. It is 2 moles of Cl dot which you are seeing. So I made the correction, so I removed the cross. So it is like this, 2 moles of Cl dot. Now, chlorine free radical, once you are getting, it will attack the methane molecule, and that takes the reaction in the forward direction. How? So you can see it in this manner. This is the free radical. Don't give a plus sign. You can write CH3H and you can write here Cl dot. What happens here is CH3 dot and H dot is formed. H dot and Cl dot forms HCl, and here you get a methyl free radical, CH3 dot. So the methyl free radical that is obtained, CH3 dot, again it will react with Cl2, and this forms Cl dot and Cl dot, and CH3 comes and combines with 1 electron. 1 electron of CH3, 1 electron of Cl forms CH3Cl, and this is a Cl dot. This is how the mechanism is. So please see the mechanism, do the required correction in your NCERT textbook. Now, the chlorine and the methyl free radical generated above, that what happens? It happens in a stepwise manner, and you can see in the propagation step, here we can see CH3Cl plus Cl dot, here again a CH3 dot and a Cl dot. So this happens in a stepwise manner, and so you get these products over here. So termination means whichever free radical you have got, they combine amongst themselves and gives you Cl2, CH3, 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 Cl and so on. That is called a termination step. Combustion reaction that takes place in alkane, in any of the hydrocarbon, the products of combustion are CO2 and water. So carbon dioxide and water, it takes place with evolution of large amount of heat, as this reaction is an exothermic reaction. So it produces large amount of heat. This is delta Hc. Okay, so standard enthalpy, combustion enthalpy. This is it. So it produces huge amount of energy. So the negative sign is there. Exothermic reaction. This is again delta CH and this is H naught. Okay, so here we can see that a general equation is given. You need to see this general combustion equation. This is important for any of the alkane. You can place it in this equation and you can easily write the chemical reaction. So you can practice only the general equation. Next, you go to isomerization. What happens in isomerization? On heating, in presence of anhydrous aluminum chloride and hydrogen chloride gas, HCl gas, see anhydrous AlCl3 and HCl gas, you get isomers where you get branched chain isomers. Okay, so here the minor products need not be reported. You write the major products, and this is the isomerization. N-hexane gives the branched isomers. Next, aromatization means alkanes forms aromatic ring. Now this takes place at a high temperature. So you have to remember it's a dehydrogenation, removal of hydrogen. So I can say minus 6H2 can be done over here, or minus 3 moles of H2 if I write, then 6H will be removed from here. So what happens is it's a cyclization process, and here it is aromatization or reforming process. These are the criteria: chromium oxide, vanadium oxide, molybdenum oxide at such a temperature and pressure. You can always form toluene also. Toluene can be obtained. See, toluene can be obtained from N-heptane. You can obtain toluene using the same reagents. Next, reaction with steam. With steam, this will be H2O and this will be steam, of course. So when you use nickel and you actually form carbon monoxide and dihydrogen, CO and H2. Okay, so pyrolysis means higher alkanes heated at a higher temperature, they decompose to give you lower alkane, or it can be alkenes as well. So this is known as pyrolysis or cracking. Other name of pyrolysis is cracking, and this is the example that has been given to you for pyrolysis, producing other products. So that's all for this session. We are going to meet in the next session with conformations. Till then, bye all of you.